Looks what arrived on the mail. That's right, the print for Beetle. My phone didn't print them. This thing just arrived, and now you could see what I did to it. Yes, I have opened it before, more on that later. First thing that I did is to install all the jumpers according to the small documentation that I found. I plan to use A4988 for all Z axis and the M6 for A, B, and E axis. As you could see in the unboxing, I did install JSC XH connector because the very first time I plugged this thing in, I accidentally tried reverse polarity protection feature of it. To prevent it again, I decided to install those. For the fan, one of the fan is 12 volt, while the other is 24 volt. Inserting the jumper according to what I said before. Okay, the mobile is done. Now, we shift to the drivers. Luckily, the lid is pre-soldered, and what I need to do is to just install the heatsings, making sure the heatsink ain't touching those pins. Then I install it on the mobile. Remember, the orientation is important this time. Do not get it flip again. Then store it in the box, because the next few days later, it's time to flash the firmware. Wait, already? Where's the Z and E extruders? But before that, I assumed that I could change the driver assignment via the software. Don't get me wrong, it could be done, but not worth the effort. So I just moved the drivers instead to pre-assigned setting. Okay, back to flashing. I use Marlin, cause why not? Fortunately for me, this motherboard manufacturer give example code for the board. And what I need to do is to just change the code a bit. And I use auto-build Marlin to compile Marlin. Oh, I did test this early because, well, I can wait to test this mobile. So, here we are, only AB drivers. This controller presents two COM ports to the PC. So which one is which? Yeah, I got confused, but eventually I could connect it, and good news everybody! The printer is now online. Okay then, installing the printer. I know it's janky. Yes, it's thin rail on this printer, and yes, I haven't cut it out, but I will eventually. Okay, back to topic. Moving it on the x-axis. Wait, it did what not it's supposed to do. Checking it if I forgot to set it into XY core mode. Nope, it's in XY mode. I hope it's the YM to prove it.
Let me switch. Oh, install this music. Okay. Yeah. Oh yeah, 1 hour. Okay. Okay. Oh,
Yeah, it's still the same. One side is loose, the other is stiff. Oh shit, I hope the driver is okay. Trying to flip the driver itself and...
okay. Oh, what is that? But not cable. Ah, cable. Let's try another move one. Either move one or cable.
So the motor needs to be replaced then. One of the motor is holding, which means it's unpowered. So should I replace it at that or now? Okay, replacing the motor. Pulling it out by unscrewing the pulley, then lower the belt tension. Here's the old motor. See those black lines in the shaft? Yep, turns out it's just the screws is loose. Oh well, it's already out. Might just replace to match the other side. Good thing I tested it. Yeah, and the face is flipped. Flipping it off camera, and here is the result. Then I installed it again, the janky way. Then testing it again.
Ow, that's loud.
Indeed it is. I do not know where it came from, but our candy direction is wrong. Perhaps AP motor is flipped. Assume the direction too. Is the fix could be done off camera. Hey, the C driver is finally arrived. Yep, you know the drill. Installing the heatsink for every single one of them except one. I bought extra. Then installing it to the motherboard, mind the orientation this time. It's really important not to get that flip. Now we shift attention to the mobile returner. Since this mobile never been used before in the forum, or perhaps my forum repository is just too old, I need to create my own retainer. Next is thin rail. I need to cut it first, then install those retainers to the thin rail and screws the motherboard in. Next is the PSU. Because to set the current for the A4988, I somehow need 24 volt power. Now setting the current, my motor is rated for 1.2 amp. And my driver come with the current resistance of 0.1 ohm. So here is my calculation. The calculation said 0.8, so I will set it to 0.8 volt to on the Z-axis. Okay, then testing the Z-axis. At first, I took a small step just in case the Z-axis polarity is reversed. Some drew, and I need to reverse it, so they move in the same direction. Yeah, because it is much easier to flip it on real life rather than in software. After it all done, I started to step it a bunch, and it worked. All axes move at the same rate and at the same direction. We even have full range in this test. Oh, that's what making it skipping the chain. Only me and my friend Dev knows. And next testing the fan. Oh no, only one of them works. At first I could panic because I only have one of those fans. But after testing it with my handy dandy battery, the fan is fine, luckily. Well, the snake is broken now. Added to the list of problems. Okay, the limit switch. Gonna be different from the manual here. I decided to put at the top. Why? Because since it's a bit different, I need to create my own custom part. Here is said part. I need to split the carrier so it could be printed without any support. Begin by chamfering the holes, then installing the limit switch. There is one small problem here. To fix it, then install the carrier with the help of screws. The screws are a bit longer, and yes, I have done it before. Yeah, should go with the shorter one, I guess. Nobody sells 9.5mm screws. Oh, here is close-up view on how this carrier will be installed in the frame. After the carrier is done, it's time to switch our attention to the wires. I use GST SM4 pin connector. I use it cause I'm planning to use industrial current loop. I will explain it in my future project, but for now, I'll use it as is. Why I decided to complicate it, you might ask? Well, the reason I built this printer is to create a prototype for my own bigger 3D printer, and I also need another printer to print this part. My current printer, the resin one, ain't big enough for that, and I will be installing these limit switches on the future video. Sorry, regarding the head, what I really want is to test this extruder motor only, but Marlin would not let me to do so. So I need to test this two part in one go. Extruding, it just rattles around and would not even the plastic through. So I push it manually and here is the first extrusion. After flipping the face, the stepper is finally able to rotate correctly, but at the cost of this 3A4988. Yeah, it's my own fault. I haven't changed the current rating. Pizza. Sykes is the build plate, as specified by the build guide 8mm intake. And our first order is finished to clean it. See all those greasy fingerprints? It will interfere with our adhesive stickiness. I use acetone to clean them. That was all those nasty fingerprints of the factory. Oh, don't be like me. Please use aspirator, especially in a confined space like a room. Ooh, box of goodies. This contain a magnetic plate and a heat pad. I needed the magnetic sheet, that's why I'm pulling this out. Yep, never gets old. Then keeping the spring still in a safe place for later. Okay, attaching the magnetic sheet to the build plate. I use gloves to keep me from reintroducing my oily finger to the plate. Well, I do think my glove isn't compatible with acetone. Taking it off, I use caliper to center the magnetic sheet to the build plate. I center it by equalizing the left and the right side of it. After I'm sure it is centered, then contact. I use a bottle and a spatula to help me push the magnetic adhesive. Then peel a bit more, squeeze it, peel a bit more again, squeeze it, and so on. At the end, I started to peel from the left side to the right, like that. I did all of this to prevent bubble from forming, but some managed to form. No worries, I need to wood free those bubbles. Now punching the screw holes. Then, using a new blade, cutting it out carefully. I do not think I need to punch the smaller one too. Next is the hot bit. I use a measuring tape and a calculator to find its center. Then cleaning it using an acetone, and I decided to tape the cables to the silicone pad to prevent it from flapping around. Can using caliper to equalize the left and the right side of it to find its center among the left and the right side of the build plate. Then attach it to the build plate with the same method I described before. Then I decided to push it with the bottle and spatula again. Perhaps the bubble formed because the bottle isn't solid enough. I have problem with sleeping. Then after it all was done, I started to attach the cable according to the schematic that the build shows. Oh, at first I decided to attach the fuse on the heat pad itself, but yeah, I haven't bought the silicone FTV, so we just install it to the build pad itself by using M3 screws. Yeah, I'm kinda too lazy to pick up my pliers, so I use my wire strippers to crimp it. And finally the temperature port. Yeah, it is much easier to crimp the cables than soldering it. Okay, after it all was done, next is to store it in a safe place. Okay, the pit is finally done. Our separate servers are fresh, and all limit switches are ready to go. It's time to assemble it all together. In the next video, and hopefully in the last video of this series, we will finally assemble this printer into one functional printer. See you there then, letter getters. I could not resist. I've done eating. I think the next video will be late about 1 week. I think there are a lot of things happen within this first week of this month. So yeah, I'm also so sorry for a lot of things that I need to censor. I were thinking when I'm recording that parts. Yeah, nothing more to say. Bye.